Problem number 4, a 200 mm diameter pulley is prevented from rotating relative to 60 mm diameter shaft via 70 mm long key, as shown in the figure. If a torque T is equal to 2.2 kN is applied to the shaft, determine the width B if the allowable shearing stress in the key is 60 megapascal. So, first thing na gagawin natin dito is to draw the free body diagram. If this is the pulley here, we are referring to the key, itong key yung kinalayan ko ng pula, and this is the key, itong pulang to. We are asked to find the width of the key, which is denoted as B. So, gagawa muna tayo ng free body diagram. So, we have here the diameter of the pulley, which is 200 mm. So, ito yung kinulayan ko ng blue. So, dito, ito yung blue and this is the blue. And kung makikita natin dito, nagkulay ako ng green and green here. Ito naman yung shaft. And the diameter of the shaft is 60 mm. So, we have here 60 mm. Now, if this is 60 mm, so kalahati ng diameter, that is the radius. And the radius is equal to 30 mm. So, we have here the direction. Kung nakikita ninyo, ito yung arrow na to. This is the torque. So, this torque here is equal to 2.2 kilonewton meter. Ito yung arrow na to na counterclockwise. Makikita ninyo naman dito na this is the direction of the torque. So, we have here 2.2 kilonewton meter. And this is the force F. So this force F here is the force preventing the shaft from rotating, which is applied here at the key. So equating the torque and the force, so we have here the torque is equal to the force multiplied by the distance. So since torque is equal to 2.2 kilonewton meter and the force F here is unknown, and we have here the distance, so this distance here is 30 mm, so that distance is this D here. So we have 30 mm. For the consistency of units, and we are going to bring everything in Newton and then mm. So this kilonewton is 1 times 10 to the 3, and this meter here is 1 times 10 to the 3, meaning this is 2.2 times 10 to the 6 Newton mm. And this is equal to force multiplied by 30 mm. So, solving for the value of F, we have 2.2 exponent of 6 is equal to the force, denote natin as X, multiplied by 30. Shift, solve equals, and we have here 73,333. So, 73,333.33 Newton. So, if we are going to draw the free body diagram of the pin, so isolate natin siya. I-isolate natin tong part na to. Since this is acted upon by the force F, so kung ito yung pin, kung i-highlight natin to, kung titingnan natin, kalahati ng pin ay nakabaon dito sa shaft. So meaning, ibig sabihin yung kalahati lang yung acted upon by the force F. So this force F is the resultant of the uniformly distributed force acting on the pin. So if we are going to idealize the force acting on the pin, so ito siya, and this is uniformly distributed load. And this force F here is the resultant of that load, which is acting on the centroid. So that's according to the definition of the shear stress that I mentioned earlier, that this V here is the resultant of the shear force acting on the area being sheared. So since we are interested in the width B, and this key here has the length of 70 mm, so in this case this force V here is equal to F, which has already been computed, equal to 73,333.33 Newton. So from the definition of the shear stress, so we have the shear stress is equal to the force V over the area. So we have here stress, which is limited to 60 megapascal, that is equal to the force B, which is equal to F, that is 73,333.33 Newton over the area. So the area kung saan, since this is a shear force, so the area to be considered is the area parallel to the shear force. So in this case, ito po yung area na i-consider natin, and that is 70 multiplied by B. So this is 70 mm multiplied by B. So computing for the value of B, we have 60 is equal to 73,333.33 over 70 multiplied by X. Shift, solve equals, and that would give us 17.46 mm. So this B here is 17.46 mm, and this is our answer.